Hello and welcome back to Cracking the Cryptic, and an intriguing puzzle tonight. Now, just before I do that, I'm going to mention that soon on Patreon, I don't know quite when it's going up, we're going to put up my monthly tussle with the Times Monthly Club Cryptic Crossword Special, which is an absolutely vicious beast of a puzzle that I wrestle with, and the usual half hour or so this month. So that'll be going up on Patreon at some point soon for those interested in crosswords as well. Now, this puzzle, unsurprisingly, given what it looks like, is called Rainbow Flag Sudoku from Quentin Komar. I think it's his first puzzle. Thank you very much for sending it, Quentin. He sent it to us in Pride Month, I think, last month. So there we go. Now, the rules are that we've got some thermos on which, as usual, the numbers have to increase. We've got some cages which all add up to X, and we have to establish what X is. There are 6 of these cages. Numbers can repeat in the cages. It's not like a normal killer. And we've got the stripes. Now, the coloured stripes all add up to the same total, which is going to be a different total from X, I assume, but is the same total for each of the stripes. So there we go. Those are the rules, as well as normal Sudoku rules. Do have a try on the link below the video. It looks very colourful in our software. And let's see how we get on. Let's get cracking. So where to start? Well, we've got a long thermo, so that's quite appealing. 3, 4. I'm entering the possible candidates on each cell of the thermo, given that it must increase all the way down. There's only 2 possibilities in each one. And this last cell in the column, that can't be 1, 2, or 3, because if they were on this thermometer, they'd have to be in the first 3. So therefore, the 1, 2, and 3 in this column have to be on the thermo. So we get some given digits effectively. Now, that done, one of these is 1 because of the 1 already in column 5. Don't really know how to, I mean, it could easily be 1, 2, 3, 4 along there. That would make it 6, 7, 8, 9 with a 5, but that's possible. Not sure that the thermometers are much more immediate help. I may be missing how they are. Oh, well, this one up here, actually, can't be 1, 4, 7, or 5 for the first digit, so it's got to be 2, 3, or 6. So this has to be higher, 3, 4, no, not 4, 3, 7, or 8. And the last cell, 4, 6, 7, 8, or 9. So quite a few possibilities there. It's quite interesting. That forms a cage with the 5. It's almost as if we might be able to get a clue about the number that X represents. Right, the stripes, they all have to be the same number. Now, yeah, what that means in the context of the geometry of this puzzle is that since each row has to add up to 45, being the totals of 1 to 9, the other 2 cells in the row that aren't on the coloured stripe have to add up to the same number, whatever that is. So, they've kind of got to form a thermo going the other way on the other side, haven't they? So what could they be? I mean, this one could be, well, theoretically at the moment, any of 3, 4, 6, 7, 8, or 9, just from Sudoku 2, 1, and 5 being ruled out. But 2 and 3 would make 5, and that's obviously going to be impossible. Those 2 are going to have to add up to the same total, as the red stripe must add up to the same total as the purple stripe. So whatever this number is, it's almost like a Y for this puzzle. 2 plus that. It's got to be at least 7 plus something, so it's got to be at least 8. So we can take 3 and 4 out. Now this is adding up to 8, 9, 10 or 11, which would require the 3 to need a 5, 6, 7 or 8. Well, it can't have a 5 because we've already got 5 in the box, so we can take that and the 6 out of there. And you can kind of see this thermo beginning to form going up these, or going that way up these cells. So to make, what have we got? 9, 10 or 11. To go with the 4, 5, we would need something between 7 and 4. 4, 5, 6 or 7. This one must be 3, 4, 5 or 6. This must be 2, 3 or 4, not 5 because it's already in the row. I think this must be 1, 2 or 3 therefore. 8, 11 to 8. Don't think, yeah, it could be 1, yeah. So those are all possible. Now, what else can we conclude? Yeah, if this was an even number that this was making, so this would be an 8. That's okay here where you can have 2 and 8, but somewhere down the row, 10 would obviously be the number, you'd have 3 and 7. But wouldn't you need a 5 opposite a 5, which would be impossible? I suppose this might not have a 5. That could be 4, 6, 7, making this 6, 4, 3. But where would 5 then go in column 9? It would have to be here, I think. You'd have 8, 7, 6. Well, you'd still have to put 9 in this column. This wouldn't allow this to be a 1. So you'd still have to put 9, 5 and 1 in the column, which would have to be 5 there, which I don't think is possible because this has to be bigger than 3. Maybe it is possible to have 5 there. I was just thinking that 5 there would require 9 there, and you can't put 1 there. So, in fact, yes, that's the more important point, is where would 1 be? If these added up to 10, the cells in row 1 and 9 beside the stripes, that couldn't be 1. The only place you could put 1 is here. 9 and 5 would have to go in the other 2 cells. That would have to be 9. This would have to be 5. 1, 2, 3, 5. Oh, it is possible. It's not possible. It's actually not possible. If this was 1, 2, 3, 5, these 3 cells would all have to be bigger than 5. You could put 4 there, but these would all be from 6, 7, 8 or 9. And that would make 5 cells bigger than 6, 7, 8 or 9 in that box. I'm sure this is not how you're meant to progress, but it does prove that these cells do not add up to 10. So I'm going to take 8 out of there and 7 out of there. I mean, it was always going to be difficult for a 5 and 5 pair to not exist here. So that's not a shock, but it's a bit of an odd way of proving it. But anyway, it gets it done. Now, is there a problem with either 9 or 11 for those totals? If it was 11, that would be 8 and 3. That would be a must. So this would have to be 8 and 9 up here. That would be a 9. Ah, with 8 and 9 there, yeah, that is a problem. Where are 8 and 9 going to go in the bottom row? 1 can go here, but this can't be 8 or 9 because it would be under an 8-9 pair up there. That's absolutely crazy. Let me just check my logic there. I think that's right. So if 11 was the total of these cells, that would have to be 8 and 3 down here. 4, yeah, because of the kind of effect. Yes, this would be 8 and 9 to make up the 11 with those. So we'd have 8, 9 there, we'd have 8, 9 here. Where would 8, 9 go on the bottom row? One of them could be there, but none of them can be there, and none of them can be there. So there is nowhere. That can't be 8 or 9, if that's 8 or 9. Wow, okay, so it doesn't add up to 11. Again, that's pretty complex logic for getting there, and those people who criticize me for doing complex things and point out the easy things will have a field day today, but there we go. We've got there anyway. 9 is the total of these 2 cells, and for each 2 cells beside the stripes. I mean, what I'm saying is the stripes add up to 36, which is 45 minus 9. So we've got a 6 there. This has to be, that's a 4-5 pair, whichever way round in row 4. Let's just keep reducing those. Okay, so 9 is the total of those. That can't be 6 or 7 anymore. One of these is a 1, but that's probably not all that helpful. Yeah, we've still got 8 and 9 to put in these rows. Now that, being 8 or 9, would make, yeah, that's impossible, bizarrely, because that would make row 8's outies that aren't in these 2 cages add up to 17. Oh no, that is possible. I was going to say that would leave an odd number for these, but actually it would leave an even number, so that is possible. 17 from 45 is 28. They'd both have to add up. That would make x 14. Oh, well, hang on, up here. How could x be 14? 5, 4, 3, 2. Okay, it could be. And that would put 8 or 9 here, and 8 or 9 here, if x was 14. 8, 9, 7, 6. So this would now have to be 5. We'd have this 5, 3, 2, 1. And again, we'd run into this same problem of these 3 all having to be more than 5, which is impossible because those 2 are as well. Good grief. Okay, so that is not 8 or 9 here. And that's very significant because in column 9, we can now fill in 8 and 9 here. We also know that x is not 14 because that would require this to be 8 or 9. So this isn't a 4 because that would force 5, 4, 3, 2 in the cage up here. So, do we know about this? It's 5, 3, 2 or 1. Can we make any more deduction about x from this row? 2 lots of x plus, well, oh, well, these have to be odd in the same way we were discussing. So it's either 9 and 2, which is 11, which would make x half of 34, which is 17. I don't think that's possible up here. 13, 16, 18 is the minimum for x. Well, that's interesting. 18 is the minimum for x. That's 36 plus 8 plus 1 is the only way to do it. Brilliant. So we know loads of things suddenly. 18 is x. 8 and 1 on the outsides are there. This is all the minimum values to make 18. So we can do the 9. That 1 has forced the whole of this imaginary thermo. We get an 8 down there. Oh, that 8 has forced the whole of this real thermo. Wow, we've suddenly got loads of the grid filled in. Now, I think this has been a fairly complex route. Now, x is 18, so where am I going to put 4 in the top row? Not here because it's in the same box, not there because it would make that cell in this cage impossible. So it goes here. And in fact, these two have to add up to 16, so it's obviously 7 and 9. X is 18, 11 and 7 here, can't be 4, 3, can't be 5, 2, must be 1, 6. Remember, in this puzzle, I think once we heard the rule that cages could include repeated numbers, we kind of knew it would happen, and there it is. 9 and 5 here, it must be, it's 14 more. Yeah, we can put them in. 2, 3, 7, 6 here. 7 must be there because of that 7 and that 7. That's either 3 or 6, and these could be any of 2, 3, and 6. Now these thermometers at the bottom are begging to be solved. There's obviously a 9 here. 1, 2, 4, and 7. This is 3, 5, or 6. Maybe that's not very easily resolvable yet. Let's do some regular Sudoku then up at the top. So 6 in box 1 has to be here because of that 6. We can finish the box because of that 8. Take a 6 out of there as a possibility. Across the purple stripe, 5 and 8 must be there because they appear in that box, so we can finish the stripe. 7 and 9, they're resolved by the 7 and 9 down here. That's going to mean that one of these two's a 9 for what it's worth. Now 1 and 2 here, don't know which order yet. Oh yes, we do, because 1 and 6 are looking straight at that cell. Sorted. 5, 3, 2, 1, 6, 4. I'm looking down column 8 now. So 8 has to go there, and then 9 and 7 fill in down here. 3 and 6 to go there. I mean, I'm prepared to bet that's a 6 to make the thermo easier, but that's not logic, that's just guessing. 2 in one of those, 7 in one of those, and 9 in one of the others. It's a triple. What about box 4? 4, 5, 6, 8, 7 and 9 are a pair in column 3 there. 2, 1 and 3 are a triple in the other cells, which isn't very helpful on their own, but with 7, 9, 8 up there, we've got 6, 4, 5 to go in down here. So 6 and a 5, 4 pair. This is a 1, 2, 3 triple, but this one can't be 1 because it's on a thermo and not the bulb. So the 1 is there. 7, 1. 6, 5, 8, 3. Right, let's have a look at column 4. 6, 5, 9, 2, 7 in it already. That's... Oh, well, look, this can't be anything higher than 2 because it's on the thermo before 2 or 3, so that's a 1. 1, 7. This is lower than 6, could be 2 or 4. Can't be the 1 anymore. 1, 7, 2, 6. Yeah, this is a naked single. 3 now, meaning it can see all the other numbers in its column and row in this case. We can finish the column. 8, 7, 1, 9. 2 in this box now has to be here, unsurprisingly, but that sorts out the 3, 2 pair. That has long been disambiguated. This isn't 3 anymore. In fact, that is resolved. Yeah, they're all resolved along the bottom. So all the thermo's done now. 4 and 6 here are resolved, and I think we're just finishing off now. Oh, hang on. I was going to say I've got an impossible deadly pattern of 1s and 6s, but I've forgotten one of the cages. Now this cage has to add to 16. No, was that the number? 30? No, it wasn't the number. 11, 17, 18. That's the total of the cages. I'd forgotten it. So how could that be 6? No, is that the right question? I don't know what the right question is, but we've got to make this 18. So we need 16 more than the 2. This is 9 or 8, isn't it, from the column? Okay, so this can't be 6 or we'd blow the total out of the water. 3. These have to be 8 and 7. Yeah, they do to get to 18. Right. So that sorts out our 9, 7 pair. For some reason, I thought one of them was going to have to be a 9, but happily not. And I think the rest of it is now coming just by simple eliminations. So that's a really nice puzzle. I mean, I don't know. Those breakthroughs I made at the beginning are probably not the way you're meant to get into it, but the possible numbers down here were quite suggestive, and I could see those steps ahead. So I hope you don't consider that a bifurcation. I don't think it was myself, but whether it was the pure logic that Quentin intended, I'm not absolutely sure. I'll be very interested to read your comments, how hard you found this, and how you went about solving it at that stage of the puzzle. Thanks very much for watching. Hope to see you again soon on Cracking the Cryptic. Bye for now.